In this presentation, we'll discuss information that is specific to design. Go to our website, www.presbyenvironmental.com, to find a Presby representative in your area. You can also submit a request for information or find technical support by emailing us at info@presbyeco.com. During this training video, we'll cover many of the requirements to successfully design Presby systems. However, to have a complete understanding of the product and all its features, you must read the most current version of the Presby manual. You can visit our website to download the latest edition. Now let's discuss some of the general design requirements. The tables in the manual will provide the required sizing information needed to design a Presby system. Table A shows the acceptable soil application rates when either the percolation rate or soil texture is known. The application rate is used to adequately size the system sand bed area. Table A also shows the acceptable system and site slopes, and finally the allowable bed configurations for a given application rate. Depending on the application rate, different slopes for the bed and existing terrain are allowed. Bed configurations are also dependent on that application rate. In general, the better the application rate, the more design options are available for the site. Table B shows the acceptable pipe loading rate per foot for both residential and commercial systems. This assumes normal effluent strength as defined by the manual. For high-strength effluent, contact Presby Environmental for recommendations. To find the required amount of Presby pipe needed, divide the daily design flow by 3. More pipe is always allowed, but never less. Table C is used only for single-level systems and provides a quick way to find the number of Presby rows for a given row length. It also helps to find the pipe layout width for a given row spacing. To use the table, find your selected row length in the far left column and move right until you intersect a column that shows at least the minimum amount of Presby pipe required. Next, you would move downward until you intersect the number of rows required at this length. And finally, continuing down even further, find the pipe layout width for your chosen row spacing. Remember, 1.5 feet is the minimum center-to-center distance. The pipe layout width is helpful in determining the amount of system sand needed to cover all the Presby rows. Once you have determined the pipe layout width for your spacing, you just add 1 additional foot. This will provide 6 inches of system sand beyond the outer edges of the rows. Table D is used only for 2-level or what we call multi-level systems and provides similar information as Table C. The number of rows is divided between an upper and lower level. This configuration is reserved for soils with higher application rates. Continuing with our general design requirements, all Presby rows must be laid level to within 1 inch end to end, regardless of the row's length. The minimum center-to-center row spacing, as we mentioned earlier, is 1.5 feet. The designer is free to increase this at their discretion. However, you will use more system sand than would be required at the 1.5 foot spacing. Separation distances to bodies of water, wells, and other restrictive features are measured to the outermost edge of the Presby pipe and not the edge of the system sand. All Presby systems, regardless of design flow, are required to be vented. You'll remember from an earlier presentation, this is done to ensure the field will remain aerobic or supplied with air. The coarse sand in direct contact with the Presby pipes is called system sand and must be free of all organic material. System sand is defined in detail in the manual. Effluent filters are popular, however, they are not needed or recommended for use with Presby gravity systems. They can reduce airflow through the field. When dealing with high-strength effluent, contact Presby Environmental's technical support for design recommendations. You'll see a definition for what constitutes high-strength effluent in the manual. Now let's outline the general design process. The manual breaks these tasks into 9 steps depending on the system being designed. In general, the following procedure will be used. First, we need to find the soil's application rate from Table A using the soil's texture or percolation rate. We can then calculate the minimum system sand bed area required by dividing the daily design flow by the application rate. Table A will also provide the allowed system and site slopes as well as the allowed bed configurations. Next, we calculate the Presby pipe required by dividing the daily design flow by 3 gallons per day per foot, which is taken from Table B. We can then decide on a row length that is suitable for the site. Once we know the row length, we would then divide the Presby pipe requirement by our row length to determine how many rows will be in our system. Depending on the daily design flow, a calculation must be done to determine the minimum number of serial sections that are needed. This would not apply to systems using the parallel or distribution box configuration, where each row is connected directly to the D-box. Then we move on to calculating the minimum system sand bed width. We have 2 issues to contend with. First, the sand bed width must provide enough sand bed area to satisfy the minimum area calculated in Step 1. Then we must always make sure there's enough sand to cover the Presby rows. The system sand bed length will always be 1 foot longer than the Presby row length. This process is best illustrated by working through design examples. Let's work through a design example taken from the manual. We'll use a daily design flow of 3 bedrooms at 150 gallons per day per bedroom. This results in a daily design flow of 450 gallons per day total. The soil is a fine single-grain sand and has been assigned a percolation rate of 10 minutes per inch, which translates to a soil loading rate of 6.74 gallons per day per square foot, found in Table A. Our site has a 10% terrain slope, and we'd like to construct the field parallel if Table A allows. We'd also like to use a basic serial layout if allowed. And finally, there are no site restrictions that would limit the bed's length. Now let's work through the design steps. We'll follow the steps outlined in the manual. In Step 1, we find that the Presby soil loading rate for 10 MPI soils in Table A is 6.74 gallons per day per square foot. To find the minimum system sand bed area, we divide the 450 gallons per day daily flow by our application rate of 6.74 gallons per day per square foot to find we need at least 70 square feet of system sand bed area to adequately disperse any liquid leaving the system. For Step 2, we use Table A to verify the maximum system and terrain slopes for our loading rate. In this example, Table A will allow our bed to slope as much as 25% and be placed on terrain that slopes up to 33%. Our system and terrain slopes of 10% for this example are well within these limits. In step 3, we find how much Presby pipe is required for our 450 gallon per day loading. Table B allows up to 3 gallons per foot of Presby pipe. In this example, we divide 450 by 3 to find that we need at least 150 feet of Presby pipe. Step 4 confirms the number of serial sections required. When using a serial layout, the manual requires 1 serial section per 750 gallons of daily flow. In our example, we are using only 450 gallons per day, which is well below 750. So we can use a basic serial layout. This will allow all the Presby rows to be connected in a single series, much like sausage links. Step 5 requires a row length be selected that is suitable for the site. In our case, we'll use 50 feet because it divides evenly into the required amount of 150 feet of pipe. This will provide 3 rows. In step 6, we need the pipe layout width to help calculate the amount of sand bed width that will be needed to cover all the Presby rows. Using table C, with our row length of 50 feet and 3 rows, we find our pipe layout width is 4 feet when using a 1.5 foot row spacing. Remember that the pipe layout width is simply the distance from the outermost edge of the first row to the outermost edge of the last row. In step 7, we calculate the minimum system sand bed width needed to satisfy our area requirement from step 1. To do this, we divide our 70 square feet of area by the sand bed length, which will always be the row length plus 1 foot. In this example, that would be 51 feet. This calculation shows a minimum sand bed width of 1.4 feet needed to provide enough dispersal area for the liquid leaving the field. Step 8 calculates the minimum sand bed width needed to cover all the Presby rows. To do this, we take the 4-foot pipe layout width from step 6 and we add 1 foot. In our case, that results in a minimum sand bed width of 5 feet. This value is larger than the width calculated in step 7, so we must use this larger value. Step 9 asks if a system sand extension is required. If the minimum sand bed width from step 7 was larger than the width calculated in step 8, there will be a need for a system sand extension. If the bed were level, the extensions would be placed equally on either side of the Presby pipes. However, our system is sloping, so any extension would be placed entirely on the downslope side of the field. Because the sand bed width in our example needed to cover all the rows was larger than the width needed to satisfy our area requirement, no sand extension is needed. There is one other consideration, and that is the slope of the field. The manual requires a minimum 3-foot system sand extension on the downslope side of beds sloping over 10%. Because our system is only sloping 10%, we don't need this additional sand. Now let's look at an illustration of this system. Because our daily design flow was less than 750 gallons per day, we were allowed to use a basic serial layout. With basic serial systems, you are not required to use a distribution box, so this system can connect directly to the septic tank. A vent stack is connected to the end of the last row in the series. This will provide air to every foot of Presby pipe. If any portion of the field extends above the original grade, fill will be needed to be placed around and over the field. The side slope tapers are used to blend the mound back into the surrounding terrain. These side slope tapers cannot be steeper than 2 to 1. Consult the manual for all the elevated system requirements. Let's work through another example. This time, we'll design for a 1,000 gallon per day commercial multi-level system being placed on 30 MPI soils. This time, the site is level, so our bed will also be level. We'll use the minimum 1.5 foot row spacing. This site has a constraint that must keep the bed 40 feet long or less. Now let's work through the design steps. In step 1, we use Table A to find the equivalent soil application rate for 30 MPI, which is 2.25 gallons per day per square foot. Dividing our 1,000 gallons of daily flow by 2.25 results in a minimum of 445 square feet of system sand bed area being required. Step 2 is not needed for our bed because we're constructing it level. However, Table A would allow the system to slope up to 25%. Step 3 calculates the required amount of Presby pipe by dividing our 1,000 gallons of daily flow by 3, which provides a minimum of 334 feet needed for this treatment field. Step 4 calculates the number of serial sections required. We take our 1,000 gallon per day daily flow and divide it by 750 gallons per day per section to find that we need at least 2 serial sections. With multi-level beds, it's always preferable to feed the upper rows before connecting to the lower level. This may result in using more serial sections than is required. Step 5 requires a row length be selected. By using a length of 35 feet, we would need 10 rows to satisfy the minimum 334 foot requirement. This will allow 5 rows in the upper level and 5 rows in the lower level. Whenever possible, use the same number of rows in each level. This provides a balanced distribution of liquid. For step 6, let's use Table D to help with our calculations. For a row length of 35 feet, requiring at least 334 feet of Presby pipe in total, the table shows that when using 10 rows at least 1.5 foot spacing, the pipe layout width will be 7.75 feet. When working with multi-level systems, the pipe layout width is measured a little differently than with single-level beds. With multi-level fields, the pipe layout width starts at the outermost edge of the outermost row in the upper level and is measured to the outermost edge of the outermost row in the lower level. I'll be sure to point this out in the illustration at the end of this example. In step 7, we calculate the minimum sand bed width needed to satisfy the area requirement from step 1. To do that, we divide 445 square feet by the sand bed length of 36 feet to get 12.4 feet as our minimum sand bed width. In step 8, we need to calculate the sand bed width needed to cover all the Presby rows. Using the pipe layout width from Table D of 7.75 feet, we add 1 additional foot to provide 6 inches of system sand beyond the edges of the pipe. This provides a sand bed width of 8.75 feet needed to cover all the rows. This value is smaller than the sand bed width needed to provide enough area. So we have to use the larger 12.4 feet as our minimum sand bed width. Step 9 calculates any system sand extensions that might be needed. And in this example, there will be, because the value from step 7 is larger than the value from step 8. To find the width of the extension, just subtract 8.75 feet from 12.4 feet and then divide by 2, which provides a 1.825 foot extension on each side of the Presby rose. For practical purposes, let's round that up to 2 feet for ease of construction. Now let's take a detailed look at an illustration of this design. The first thing you'll notice is there are 2 levels of Presby pipe. You'll also notice the upper level rows are placed so that the liquid leaving them will fall between the lower level rows. This system also uses 5 serial sections, even though only 2 were required. The reason for that is so that we can feed all the upper level rows before connecting to the lower level rows. A vent manifold connects the ends of all the serial sections in the lower level. For multi-level beds, the vent is always connected to the lower level rows. This will ensure these rows are provided adequate oxygen. Because this is a level field, the system sand extensions are placed symmetrically on both sides of the Presby rows. Before we leave this slide, notice how the pipe layout width is measured for multi-level beds. The dimension spans both the upper level and lower level rows. Contact our technical support team when designing your first multi-level system, and we'll be happy to assist you. It's worth pointing out that multi-level beds can be sloping and curved to avoid site obstacles in the same way single-level systems do. That brings us to the end of this presentation. Not all the options or configurations described in the Presby manual have been discussed. Please take the time to read the manual before attempting a design or installation. And, as always, feel free to contact our free technical support. Let's review some of the key topics just discussed. Table A provides Presby soil application rates when either the soil structure or percolation rate is known. It also provides bed restrictions concerning slopes and bed configurations. The soil's application rate is used to calculate the required system sand bed area. Table B provides the acceptable Presby pipe loading rate for both residential and commercial applications. For normal strength effluent, that will be 3 gallons per day per foot. Table C is used to assist in finding the number of Presby rows for a given row length and also the pipe layout width for a given row spacing. Table C is used only for single-level systems. Table D provides the same information as Table C, but only for multi-level systems. Vertical and horizontal separation distances to restrictive features, like the seasonal high water table, are measured to the outermost edge of the Presby pipe and not to the edge of the system sand. Continuing with our review, 1.5 feet is the minimum center-to-center row spacing. The designer is free to increase this spacing if they desire. All Presby rows must be laid level, end to end, within a single inch. This is required regardless of the row length. All Presby systems must be vented. For multi-level beds, the vent must be connected to the lower level rows. Effluent filters are very popular. However, they are not recommended for use with gravity-fed Presby systems because they tend to inhibit airflow through the field. When you're designing for high-strength effluent applications, contact our technical support team for sizing recommendations. Remember, Our technical support is always free. The next presentation will introduce you to the construction techniques used when installing a Presby field. Thanks for watching.